Hi, so welcome back to 3 Inquisitive Kids. In this video, we will be starting a brand new series called Geometric Shapes Among Quadrilaterals. So this is mostly just talking about geometric shapes, and we're going to be doing geometry problems that involve mostly solving areas. So we'll be focusing less on perimeter in those things and angles and focusing more on area. So in this video, let's go look at and review some formulas of how to review some basic shapes and some points that will be important throughout these problems. So remember, areas is the big word I want you to know from this video. So these are just some formulas of how to find the areas of the shapes. So for squares, it would be its own side length times itself another time. So it would be A times A. Rectangles is equal to width times length. Parallelograms is also width times length. So this is something I will be showing you. Now this is my parallelogram, right? Well, suppose if I draw a line down here, right? You will see that it's going to become two triangles and one rectangle. The surprising thing is, what if I moved this part right here, this triangle, to this part? Then you will see that I have formed a rectangle. This would be my rectangle right here. So this rectangle is equal to the width times the length. And that's why parallelograms have the same formula as rectangles, because they can be transformed into each other. So a rectangle you can turn into a parallelogram. For a parallelogram, you can turn into a rectangle. And then, of course, there are triangles. So for triangles, it's just base times height divided by 2. Here's what I mean. This is my triangle. If I were to make the same version of it, but just flip it backwards, you see that I will have a parallelogram here. And what this is just the base of the parallelogram times its height of the parallelogram. Basically the same thing as width times length. But just to find one of these triangles, each triangle is 1/2 of the whole parallelogram. So we are going to have to divide 2. So for triangles, it's base times height divided by 2. Final one is trapezoids. Trapezoids is something that is important, very important. So here is my trapezoid. So this top right here is A. I'll name that A. And this bottom side will be B. And this is H. This is my height. So how do I find the side length for this one? So you might think to get this part over here, but that won't work for every single parallelogram. I mean, for every single trapezoid. For example, trapezoids could also look like this. So then what would you do? Here's what you can do. You can first duplicate this, and then take the duplicate and then turn it upside down until it fits like that. So this part would be B, and this part would be A, and this part would be H. Again, this is a parallelogram, as you can see. And how do we find the area of this? Well, that would just be H times a 6 side length down here, H times the sum of A and B, so that's what we have here. But if we just wanted to find the area of one trapezoid, it's going to be divided by 2. So when proving many of these areas. For example, especially parallelograms, triangles, and trapezoids. What you see most often is that we were like duplicating it and turning it into a easier shape to solve, like a square or a rectangle first. So doing problems, that's also going to be what you're going to looking for. So something that you need to master is being able to add and then cut. So for example, in some problems you'll be like okay, this is a square, but then this part is cut. But then this part is cut. So in your case, somehow you're trying to find the area of this. So what you would first do is add. So you're going to add that. You have to visualize how, okay, so right now I see a square, but it's like one part is cut off or folded in. So I'm first going to add that. And the best way to show that is using these dotted lines. And then you're going to find that area, and then you're going to subtract that from the total square, which you can get the area of this part. So this method is something really, really important for you to master by the end of this series. So I hope you can really see shapes once you get them. Okay, and then finally, let's look at some special shapes. So, a special shape would be the isosceles right triangle. The isosceles right triangle. So the isosceles right triangle is, so there's first a right triangle, and it's isosceles, which means that two of these sides, the legs, they are congruent. These are called base angles, by the way. These two are called base angles. Base angles, and this applies for only isosceles triangles. And the base angles over here, both have 45 degrees. Okay. So when somebody says isosceles right triangles, you can really picture this immediately in your mind. But again, you can think the other way around. You can also think if somebody says two congruent legs and base angles are 45 degrees, what do you immediately get? You get an isosceles right triangle. Great. So don't just always go from left to right. Also sometimes go the other direction, from right to left. So yeah, that's going to be the concept and equation we're going to be going over for this series. And let's get to some problems. See you in problem